Hello, and today we're going to talk about the division properties of exponents. So for the past couple of days, we have been working with the multiplication properties. Now we're going to do division. So make sure your volume is on. You want to turn on the volume, and let's get started. Alright, so division properties of exponents. Whenever you have two numbers or two variables with the same base raised to different powers, and it's a division problem, you subtract the exponents. So, for example, I have here 3 to the 7th divided by 3 to the 3rd. Since both of them have a base of 3, I'm just going to subtract the exponents. 7 minus 3, and it gives me 4. So here's my example. I have x to the 9th divided by x to the 5th. Since they both have the base x, I'm going to subtract the exponents. 9 minus 5. And I get x to the 4th power. So it's pretty simple when you're dividing exponents. You just have to subtract them. So let's look at this one. And remember, order matters when we're doing division. So when we subtract, we have to always take the numerator minus the denominator. So in this problem, I have w to the negative 2nd minus 4. Which equals w to the negative 6. So I get w to the negative 6, and then I do g to the 5th minus negative 3. Oops. I don't know why I did that. G to the 5th minus negative 3. Well, subtracting a negative is like adding, so it's g to the 5th plus 3, or g to the 8th. So I get w to the negative 6 and g to the 8th. Well, w to the negative 6 has to go to the other side of the fraction, so it's g to the 8th over w to the 6th. Another way to think about this is I have w to the negative 2nd, so I have to bring it down to the denominator. And I have g to the negative 3rd, so I need to bring it to the numerator. And so I'd get g to the 3rd, g to the 5th, over w to the 4th, w squared. And that's going to give me g to the 8th over w to the 6th. Because remember, it's multiplication, and you add the exponents. So it's just another way to look at it. But when we're dividing, subtract the exponents. Okay, try these two on your own. If you need to, pause the video to take a moment, but give it a shot. So I have a squared over a to the 4th. Well, that's a to the minus 4. And that gives me a to the negative 2nd. And then b to the 1st minus 3. B to the 1st minus 3. And that gives me b to the negative 2nd. So if I simplify that, I get 1 over a squared b squared. And then on this one, I have the x is squared minus 1. I'm left with x on the numerator. Y to the negative 1st minus 4 gives me y to the negative 5th. And then z to the 4th minus negative 3. That gives me z to the 7th. Simplify this further, one more step, and I get x z to the 7th. And because y had a negative exponent, it goes to the other side of the fraction. And I get x z to the 7th over y to the 5th. Raising a quotient to a power. So we've worked a little bit with this in the previous sections, but in case you're not sure, a simpler way to do it is distributing that exponent to both the numerator and denominator of the fraction. So for example, I have 4/5 raised to the 3rd power. I could rewrite that as 4/5 times 4/5 times 4/5. Or I can just rewrite it as 4 cubed over 5 cubed. And that gives me 64 over 125. So, same thing down here. I have x squared over y cubed raised to the 4th power. I'm going to distribute the 4 to both the numerator and denominator, and I get x to the 8th, because 2 times 4 is 8, because this is a power raised to a power. And I get y, 4 times 3, to the 12th. So it's x to the 8th, y to the 12th. So now try and apply that to these two problems right here. So I get 3 cubed over x squared times 3, and that gives me 27 over x to the 6, because it's a power raised to a power. And this one, I'm going to get 2 squared over y to the 4th times 2, or 4 over y to the 8th power. We've also talked about this whenever we have a negative exponent. We talked about this when we're doing negatives. If you ever have a fraction raised to a negative exponent, take that fraction and take the reciprocal of it, and then change your exponent to positive. So if I have a over b to the negative n power, take the reciprocal, so now it's b over a, and change that negative exponent to a positive exponent. So here's the example they did. They have 3/5 to the negative second. They took it, the reciprocal, made it 5/3, made the exponent positive, and they distributed the 2 to the 5 and 3, and they get 5 squared over 3 squared, or 25 over 9, or 2 7/9. So I'm going to do this one right here with you guys. I have negative 3s over t, and that's all raised to the negative second power. Well, first things first, we're going to take the reciprocal of our fraction, and I'm going to change my exponent to positive 2. Then I'm going to distribute it to both terms. So then I'm left with t squared on the numerator, and then on the denominator, oops, let me rewrite that, sorry. T squared on the numerator, and then on the denominator I have negative 3s squared. And down here on the denominator I have a product raised to a power, so I'm going to multiply both terms. I'm going to raise both terms to the second power. So I get t squared on the numerator still, and then I have negative 3 squared times s squared. Or if I simplify that, t squared over 9s squared. All right, try these last two on your own. So I have 3/4 raised to the negative third power. That's the same thing as saying 4/3 to the positive third power, or 4 cubed over 3 cubed. 4 cubed is 64, and 3 cubed is 27. So you can leave it as 64 over 27, or you can make it into a mixed number. This one, I'm going to get 4p cubed over 6e squared raised to the second power, and then distribute the 2 to both the numerator and denominator, and I'm going to get 4 squared p cubed times 2 over 6 squared e squared times 2, and that comes out to 16p to the 6th over 36 e to the 4th. But 16 over 36 can reduce, and in both of those I can take out a 4, and so this becomes 4, and this is going to become 9. So I end up with 4p to the 6th over 9 e to the fourth. Hopefully this made sense. There is no Kia quiz for this. We will work up more on this next class period. If you have any questions, feel free to contact me. Make sure you took good notes, and I hope you have a wonderful evening. I will talk to you later. Bye.